Now I'll start creating a basic demonstration on how to create a Shiny app, this time by using Golem. Golem is an art package which really eases using Shiny and maintaining a Shiny application by providing a set of templates and also a logic where we build our Shiny app as an art package. So in order to do that, we need to verify that we have both Shiny and Golem installed. Otherwise, you need to install those with the install packages function and with the names of the packages in quotes, and that's it. And after that's cleared, we go to File, then New Project, then New Directory, and here we scroll down and we go to Package for Shiny app using Golem. And here we provide a name. In this case, I will provide the name Screencast for this demonstration. And this provides a template. And this already started with an open script, which is in the dev folder. Here we have a description and a namespace. In the case of the description, this is the same description as an art package. In this case, our art package and the Shiny app are the same. And we will be working in a modular way. And here you can provide your author information, the license for this application, the dependencies, and in the namespace, here we refer to all the internal calls to make this Shiny app work. For example, if you are using deployer, for example, you should list your functions in here, but we will do this by using Golem helpers. We won't edit this in a direct way. So we will go back to the start script, which is in the dev folder, and these are all helpers. The actual contents for this Shiny app are inside the R folder. So we stick to dev at the moment, then we go down in this script. And in the description, we can provide a better title like Screencast Demo, for example. And then in the description, we can provide any description. This has to be one or more sentences. Okay, so in the name, you can provide your own name. Right, so then you can provide your own name, and then you can pass your own email, right? And then we select this and we execute this with Control Enter or CMD Enter in the case of Macs. And if we go back to the description, we will see that this actually modified the description. And now we have the information that we provided. So now we can execute the rest of the code, like set Golem options. This is fine, and this provides some internals for RStudio to make all of this work later. And we can provide MIT license, for example, or we can use any other license like the Apache license. And again, we select and we execute with Control Enter or CMD Enter. Then we comment MIT license. And I won't be adding a README at the moment. You can do that later. It's all explained in the documentation. So if you search for this function in the help, you go to the help, and there's a complete detail on how to use this, right? And you can also go to the root for use this documentation in this case, and you can do the same for Golem. I will also skip the code of conduct, lifecycle, or news. In this case, I will command with Ctrl-Shift-C. I also won't be using Git. That's totally optional, really convenient if you use GitHub, for example. And the tests are something that I will also skip at the moment. It's something useful to keep in mind for later, and this also comes from Golem. You can go to the documentation, explore the detail for this function, and if you want to read more about Golem, you can go to the documentation for Golem. Okay. I will add a fob icon just to show that Golem is just like that. You just execute these helpers, and in this case this adds a fob icon for the internet browser tabs for our Shiny app. We can use our own. So if we go to files, then to inst, then to app, and inside www we have the fob icon, and that's the fob icon that we can replace with our own. Then we have the utils UI and utils server. The UI is the user interface. It's convenient to have these helpers inside our R folder. This means this will be a part of the actual Shiny app, and then we can execute use utils server. So then if we go to GitHub and then we go to the root of the project, which is inside GitHub. Then we go to the R folder, and then we have these new files that were not here before, and these are just helpers. The actual contents for this Shiny app are inside App Server and App UI, and now we are set. So we want to proceed with the rest of the helpers in the dev folder, so we will save with Ctrl+S or CMDS, and here in R we can open the app server file, and this is empty, and I will start by just providing a function that returns a table. So I will create a function called myEmptyCars, and inside here I will pass a reactive with brackets, which means that this will be updated each time the user switches something in the UI, in the in-browser part of this Shiny app. So here I'll be calling empty cars, just that at the moment, but then I also need to provide an output for this, something that can be passed to the internet browser. So here I write output, and then with the $sign I provide a name for this, and I will call this just TBL for table empty cars. And here I will call a function that's a Shiny function, and if you pay attention at this script comes with a header which was inserted by Golem. This is part of the templates I've mentioned at the beginning of the video, and this is already importing Shiny, and in addition, in the description, Shiny is listed as a dependency, and this will be useful when we build this in a few seconds. So here I'll be just returning empty cars with no user input at the moment, nothing, just empty cars table as is. And for the output I will write render table, which is a Shiny function, and with brackets because of the reactivity in here. And here we can call the myEmptyCars function. So this is a function that returns a table. Then if I go to the App UI script, here I have a fluid page, same header structure, and here I can call the table output function from Shiny, which is being imported here. Then I go to App Server and copy this output, the output name, and call this with quotes. So here I put this. I need to add a comma to separate these header 1 and the table output. So now I save this, then I go to build, then install and restart, and this will load a new app package called screencast, which is my Shiny app. And this run app script provides a function which is run app, which is a part of this app package or Shiny app called screencast. And if I run this app, now I have my running Shiny app in here with the empty cars table. So now I can add some filter to be able to use user inputs. So I will close this. I'll go back to the app server script, and here I'll be using the pipe which is Ctrl+Shift+M. This is a special operator that I need to call internally right now, and I will write a filter, and I will filter by the number of cylinders in the empty cars dataset, which is always good to refresh. So we go to the help, then search for the empty cars, and this is the variable I will want to filter by, number of cylinders. So here I'll write something like cil double equal input, then $sign, and I need to call as a selector. In this case, the input, it's a reference to something in the UI. I need to create this input. It doesn't exist yet. So here I'll write something like filter cylinders. Okay, and that's it. But now I also need to import the pipe somehow, because this is an app package. Is a bit more strict than an app markdown document where you just do library tidyverse and that's it. Here we don't do something like library tidyverse. Instead, we go back to the start script, the start R script, and before the now you are set part, we will write use this double dots use package, and here we will be importing deployer, right? And besides deployer, we'll be calling the pipe, which is a special symbol. So we use pipe helper, and because this is a special symbol, this will be added in this utils pipe script inside our folder, which are the actual Shiny app contents. So if we have a look, this is a way to use the pipe anywhere in our Shiny app. So now we save the changes in start, then we go back to app server. But to make this formal, we need to use the tidyverse in internals. In this case, this is good for the end user, but here we write bang sim, and then in quotes we call the cylinder column, and this is a non-standard evaluation. There's a lot of information about this in the tidyverse articles by RStudio. So to use this, sim is a function from the Erlang package, and this is something to be really strict about how we call column names in our filter, right? So this is something from Erlang. So here's a short description in the documentation, and here we also need to update the header, because we are calling the filter, which is a part of the tidyverse. And what we've done here in the start script in the dev folder. So this is a helper. If we go back here to dev, what we did here in start, modified the description. That's okay, but we would also need to go to the app server script and call the filter function. So instead of calling all of dplyr, we write import from, then write dplyr, and from there we call the filter function. And then on a later stage, if you need to call a mutate or something like that, you don't repeat the import from, you just write it next to. Or if you also need a group by, you put it there. So we have that, then we save this app server. We go back to the dev folder, then we go to the dev script, and this starts with an amendment function to fix anything that's not done in a very strict way. So if we execute this amend description, this didn't do changes to our description, but without anything additional from our side, this updated the namespace to import the pipe and also to call the filter function from dplyr. So going a few steps back, if we go back to server, here we are missing the sim function, so we need to import this one. So from Erlang, we import the sim function, and we save this. And we also need that here, so we don't modify this by hand. We go back to start, and then just use the use package function, right? And because we modified our header in our app server script, we go back to app UI. Sorry, we go back to dev and run the amend description function, and our namespace now is doing all the internals to import this sim function from the Erlang package. So this is almost ready from the server side. Now we go back to the R folder, for the actual Shiny app contents. We open up UI, and here on top of our table output, we can write something to create a selector, like a slider or a drop-down list. So for example, here we can use the select input function, which needs some very specific attributes. So first we provide a name for to identify this selector, and we also don't forget the comma to separate the selector from the table output. So in server we were calling this filter cylinder input, so we call it by the same name, filter cylinder. Then we provide a title like select a number of cylinders, right? And then we provide a selected a default option, in our case 4, and then we can pass some choices, okay, like which choices. So we can use the unique function in the console, then call empty cars and explore the unique values for this and pass 468 in that way as a vector, or we can create a sequence, or as we'd like. We can also use dplyr here to create this filter. So we can call empty cars. Now we insert a pipe, which now we can call anywhere in our app. Then we can run something like a select seal, and then a distinct, or just a distinct, and we specify the seal function inside, like that, right? And then we use the pull function to convert this to a vector. So this, here I will need to load the player in the console to show the result, and also load a lang, and that's the tidy way to do this. So up here we will need to write an import from, and from the player this time we import distinct and pull, distinct and pull, and we also call the sim function from lang. And we don't do that for the pipe because it's already imported as a special operator. Now this is ready, so now we set this, then we install and restart our app again. And now we can call the app function. And now we can move the number of cylinders, and this table will be recomputed every time we switch this selection in here. And we can now open this in browser, and there's the icon that I've mentioned at the beginning of this. For the next video, I will show you how to modify the aesthetics for this kind of applications. For example, here we can click Ctrl+Shift+I, and with the inspector we can explode, for example, the header, and we can switch the color. We can pass that color, or maybe something like a royal blue. Then change the font family, and let's say pass something like a Comic Sans, for example. And we can do this permanently in our Shiny app, and Golem has a lot of helpers to ease this process. I hope you liked the video, and this is the end of this demonstration.